Welcome to the Idea Leaders Self-Learning Series on the co-creation of virtual learning accessibility. This video is about disabilities and accessibility needs regarding virtual teaching and learning. Introduction. The aims of this module are threefold. To enhance the awareness and understanding of some potential barriers that some students with disabilities may experience, and examples of accessibility arrangements or tools that could better cater to their diverse learning needs and accessibility needs. To promote effective expression and delivery of knowledge through digital educational materials and e-learning tools. To advise students and/or staff members who may need accessibility support, especially for someone with temporary disabilities who might not be aware of their needs, and possible or suitable accessibility support, adaptive strategies, and assistive technologies to facilitate teaching and learning. This module provides examples of experiences, barriers, and accessibility needs of some people with disabilities, as well as the potential strategies, design principles, tools, and techniques that could better cater to their diverse learning needs and accessibility needs regarding virtual teaching and learning. Specifically, it mainly covers people with cognitive disabilities, learning disabilities, and/or neurological disabilities, deaf people or hard of hearing people, people with physical disabilities, people with speech disabilities, and people with visual impairment. As illustrative examples. Note that the categorization and naming of disabilities here do not aim to categorize people according to any medical conditions. The examples here mainly serve as illustrative examples. The categorization and naming of disabilities would vary across different perspectives, such as the adopted conceptual models of disability, different cultures, changes in the knowledge and understanding of the conditions, or changes in preferences among disabled people and advocacy groups. Part of the content of this module is adapted from the following two documents from the World Wide Web Consortium, W3C, Web Accessibility Initiative, WAI. The first document is Diverse Abilities and Barriers in How People with Disabilities Use the Web. The second document is Tools and Techniques in How People with Disabilities Use the Web. You may find the full references on screen now. You may also refer to the text version of the reference list below the video player on the web page. About people with cognitive disabilities, learning disabilities, and/or neurological disabilities. Cognitive, learning, and neurological disabilities involve neurodiversity and neurological disorders, as well as behavioral and mental health disorders that are not necessarily neurological. They may affect any part of the nervous system and impact how well people hear, move, see, speak, and understand information. They do not necessarily affect the intelligence of a person. People with cognitive disabilities, learning disabilities, and/or neurological disabilities may have the following experiences. Difficulty processing auditory, tactile, visual, or other sensory information, affecting reading, writing, processing numbers, or spatial and temporal orientation, etc. Difficulty focusing on a single task, focusing for longer periods, or being easily distracted. Affected social communication and interaction, and habits and interests. Difficulty understanding complex concepts. Limited short-term memory, missing long-term memory, or limited ability to recall language. Difficulty focusing on information, processing information, or understanding it. Psychosocial disability experiences such as anxiety, depression, schizophrenia, and many other disorders. Difficulty focusing on, processing, or understanding information. Blurred vision, hand tremors, and other conditions due to side effects of medication. Different types of epilepsy and migraines, which may be in reaction to visual flickering or audio signals at certain frequencies or patterns. Other conditions that are not listed here. The following are examples of barriers related to virtual teaching and learning. Creative use of animation or flashing content in video may promote user engagement. However, overuse of animation, flashing content, autoplay, autoloop, or background audio that cannot be turned off may cause distraction from the main content, especially people who have difficulties in reading or concentrating. Moreover, animations, flashing objects, moving, blinking, or flickering content may cause discomfort. Content that flashes more than 3 times per second may trigger unpleasant feelings, dizziness, nausea, or seizures in some people, such as people who are photosensitive. Other barriers include the following: complex navigation and page layouts that are difficult to understand and use, complex sentences and words that are difficult to understand, long passages of text without images, graphs, or other illustrations to highlight any main points or facilitate understanding, large amount of materials to be attended to, jotted down, and/or memorized, a potentially burdensome need to concentrate on the screen for virtual classes for a long period of time, and timed actions may bring about stress to some people, such as people with anxiety or panic experiences. Examples of adaptive strategies related to virtual teaching and learning are as follows. People with cognitive, learning, and/or neurological disabilities use different types of methods to engage in virtual teaching and learning, depending on their particular needs. For example, some of them may want to resize text and spacing to assist reading, customize colors to assist reading, use captions for audios or videos, or use recording functions of video conferencing platforms to record live streaming classes for review later. Examples of assistive technologies related to virtual teaching and learning are as follows. Word prediction tools, which is in general a software that presents selections of matching words, phrases, or sentences based on the current input and sometimes the context to save typing. Spelling and grammar tools which support writing. Text-to-speech synthesis of the content. It is in general an automatic conversion of accessible text displayed on the screen into a synthesized voice. For example, screen reader software is an assistive technology that can perform text-to-speech conversion. Screen readers convert accessible text displayed on the screen into synthesized speech and braille. Examples of accessible text include readable text, images, buttons, or operating system elements with accessible text labels, and documents with accessible content. Screen readers work on computers and mobile devices. They are currently available for use with devices running different operating systems such as Windows, Mac, iOS, and Android. Examples of screen readers include the following: JAWS, Job Access with Speech; NVDA, Non-Visual Desktop Access, available for download and use free of charge, and works on devices running Windows; and VoiceOver, a built-in screen reader in devices running macOS and iOS. There are also handheld devices with a smart camera that can read aloud text from printed surface or digital screen to perform text-to-speech conversion. The photo on screen shows an example of such device called Orcam My Eye Pro. It is a voice-activated device that attaches to virtually any glasses. It can instantly read aloud text from a book, smartphone screen, or any other surface and recognize faces. Orcam My Eye conveys visual information audibly in real time and offline. Some people may use different types of reading assistant software to change the presentation of digital content and provide other functionality to make it more readable, depending on their needs. Some functions of those reading assistant software are customizing the font type, size, spacing, or foreground and background colors, and reading the content aloud and highlight the text as it is being read out loud, scanning the text for complex words and phrases and linking them to glossaries, hiding less relevant parts of the content, such as sidebars and header areas, providing outlines of the page headings and summaries of the text passages. Course instructors may consider the following examples of practices to support students with cognitive, learning, and/or neurological disabilities to engage in virtual learning. Allow short breaks for live streaming sessions of long duration. Allow recording of live streaming classes for review. Allow alternative modes of responses input, such as substituting a written response or a typewritten response with a verbal response for course assessment. Provide clear and helpful error messages and options for correcting input. Allows enough time to complete tasks. Timed activities may bring about burden to some students. Give people time to process information. Pause between topics. When you ask if anyone has questions, some people with cognitive disabilities may need more time to form their thoughts into words. Limit distractions. For example, ask participants to turn off mobile phone notifications and presenters to turn off system notifications. Discourage side conversations during meetings and presentations. The following are examples of accessible designs of teaching and learning materials. Provide an option, such as on click, to allow users to play, pause, or stop the autoplay of the flashing content if possible. This minimizes discomfort and allows users to read the content at their own pace or as they wish. Avoid too much flashing content or animation. You may refer to the Web Content Accessibility Guidelines, WCAG, from the World Wide Web Consortium, W3C, for detailed guidelines on flash thresholds and the technical formula for calculating general flash and red flash thresholds. You may also make use of the Photosensitive Epilepsy Analysis Tool, PEAT, developed by the Trace Center at the University of Maryland for measuring whether web or computer applications are likely to cause seizures. About the design of the overall content structure and arrangement. Providing consistent label forms, buttons, sections, and other parts of the content. Increasing the predictability of link targets, functionality, and overall interaction. Enabling different ways of navigating digital materials, such as providing bookmarks and/or table of contents. Providing a summary for large pieces of content at the beginning. Supplementing the body text by summaries, images, graphs, and other illustrations to facilitate understanding. And providing glossary for complex words or phrases. Hiding less relevant parts of the content to minimize distraction. For example, freezing certain rows and/or columns in Excel spreadsheets. Have a clear document outline. A well-formatted and meaningful heading structure allows users to understand the semantic structure of the document better. Users could jump between headings to look for information from large piece of text efficiently. It may facilitate information processing. It is suggested to keep headings concise, specific to the content that belongs to that section, and clear to someone new to the topic. If you are using Microsoft Word, you may make use of navigation pane to check heading structure and navigate the document easily. To view the list of headings, go to the View tab, select Navigation pane, then select the headings. You may jump between the sections for easy navigation by selecting the corresponding headings. Headings that have already been correctly applied heading styles would appear in the navigation pane. However, note that headings in tables, text boxes, headers, or footers would not appear in the navigation pane. We may change the visual appearance of the text to achieve higher readability, such as the font type, font size, character spacing, line spacing, and paragraph spacing, punctuation and symbols, emojis and emoticons, hashtag, and text colors. For font type, for example, can increase accessibility as follows. Sans serif fonts are generally preferred to serif fonts. Sans serif font do not have decorative lines at the edge. An example is Arial. Serif fonts have small lines at the edge that may hamper readability. An example is Times New Roman. Avoid only decorative fonts or light fonts. Some users, especially people with dyslexia and people with visual impairment, might find it hard to read decorative fonts, and those whose letters are close to one another. Avoid using all caps or small caps for the text. Capitalizing all text is difficult for most people to read. Text with all caps or small caps may show no differences in the shapes of texts, and all the texts may visually appear like a single rectangle. It would particularly create barriers to some people with reading disabilities and some people with visual impairment. Hashtags can be created for users to follow specific topics on websites and social media platforms. Adopt camel case in creating hashtags by capitalizing the first letter of each word and/or adding underscore in the multiple word hashtags. It could give the cue that there are different words in the hashtag. It would enhance the readability of the hashtags for everyone. It would provide cue to people with dyslexia or cognitive disability to identify the word pattern and recognize the words in the hashtag. Text-to-speech functions or software might be able to read aloud the hashtag as different words as intended. Without spaces between words in the same hashtag, there would be no cues for the screen readers to distinguish the separate words in the hashtags. Here are examples of commonly confused sets of letters that may hamper readability. When we choose a font, we may pay attention to whether the characters of that font can be clearly distinguished. Otherwise, it would be potentially confusing to readers, particularly to people with reading disabilities and people with dyslexia. The first set is about the numerical 1, the capitalized letter I, and the lowercase letter l. For example, both Arial and Noto-san show a clear distinction between the numerical 1 and the two other letters. However, the capitalized I and the lowercase letter l look very similar in Arial. It can be confusing. Noto-san's gives a clearer distinction between the capitalized I and the lowercase letter l, which may facilitate readability. The second example is about the distinction between small letters R and N and the small letter M in relation to the character spacing between R and N. When R and N are adjacent to each other in a word, and R is on the left, and N is on the right, and if the spacing between the small letter R and N is too small, the letters R and N would look like a small letter M. This can be confusing. The third set is due to mirroring between P versus Q and B versus D. Some people may experience difficulty distinguishing between P versus Q and between B versus D. The mirror images look very similar. This can be confusing. The next example is about confusion through flipping and swapping the characters. Take Arial shown on screen as an example. The flipped images of the small letter U and the numerical 9 look very similar to the small letter N and the numerical 6, respectively. This can be confusing. About deaf or hard of hearing people. Some hard of hearing people may hear sounds, but sometimes not sufficiently to understand all speech, especially when there is background noise. Some of them may use hearing aids. For some deaf or hard of hearing people, sign language is the primary language. However, it is important to remember that not all deaf or hard of hearing individuals know sign language. Some of them may communicate by lip reading. Here are some examples of barriers related to virtual teaching and learning that may affect deaf or hard of hearing people. Captions, transcripts, or sign language interpretation are not available for media content. Moreover, live captioning, live transcripts, and sign language interpretation are not available for teaching and learning activities such as classes, meetings, and conferences. Media players that do not provide volume controls, options to pause or stop autoplay and autoloop, captions and transcripts, or options to adjust the text size and colors for captions. Too much background noise. Extreme differences in sound effects. Unexpected sound or extreme differences in sound effects within the same video or audio may be shocking or distracting. E-learning tools rely on interaction using sound and voice only, or the functions or contents are mainly audio-based. A lack of sign language to supplement important information and text that is difficult to understand. Some of them may not prefer reading the written language. Providing important information in sign language and using simpler text that is supplemented by images, graphs, and other illustrations may help make the content more understandable. Here are some examples of accessible design and practice for virtual teaching and learning for deaf or hard of hearing people. Sign language interpretation. The selection and use of e-learning tools that could enable alternative modes of interaction rather than using voice only. Captions and transcripts of audio content, including audio-only content and audio tracks in multimedia. The use of media players that can provide volume control. Options to pause or stop autoplay and autoloop. Options to display captions and transcript. And options to adjust the text size and colors of captions. High-quality foreground audio that is clearly distinguishable from any background noise. Avoid extreme differences in sound effects. Keep the volume level at consistent level whenever it is possible. If there will be sudden loud noise or any potentially triggering sound in the media, provide users with a warning message and/or mention this information in the media timestamps to alert the audience. For example, audience may want to turn down the volume of their earphones before playing the media file. You are encouraged to refer to the other module on the suggested practices of enhancing the accessibility of video and audio in greater detail. If wearing face masks is required due to public health concerns, consider wearing transparent face masks. Wearing face masks has become part of the new normal due to the recent global pandemic. However, typical face masks cover the mouth and hamper lip reading and the observation of facial expressions. This particularly affects communication with deaf or hard of hearing individuals. Clear masks would facilitate their lip reading and understanding of facial expressions. About people with physical disabilities. People with physical disabilities may have the following experiences: progressive weakness and degeneration of muscles, involuntary movement or muscle contraction, such as short twitches, and continual or rhythmic muscle contractions, weakness and limitations of muscular control, such as involuntary movements, including tremors, lack of coordination, or paralysis, limited mobility, such as walking, limited stamina, partial or total paralysis, including motor control and sensation, of all four body limbs, legs and arms, and the torso, reduced movement control, such as hand-eye coordination, limited sensation, joint disorders such as arthritis, chronic pain that impedes movement, missing limbs, and/or other conditions that are not listed here. Examples of barriers related to virtual teaching and learning include the following: difficulty writing, difficulty typing, difficulty controlling the mouse, trackpad, or touchscreen, difficulty clicking, particularly small areas, inconsistent, unpredictable, and overly complicated navigation mechanisms and page functions that might require complicated control or finger touch input such as tapping, pressing and dragging, swiping, and pinching, difficulty holding or manipulating devices for immersive reality such as virtual reality goggles, insufficient time limits to respond or to complete tasks such as filling out online forms, e-learning tools that do not support alternative control modes such as full keyboard control or other hands-free interaction, insufficient stamina to support long duration of classes. For example, some of them may need to adjust posture from time to minimize pain and/or avoid pressure sore. Some of them may have difficulty being visible to the webcam all the time or facing the webcam at a particular angle for the entire online meetings. There can be different reasons for it. For example, the eye level and the height of wheelchair, desk, and webcam may not match. Some of them may need to adjust posture from time to minimize pain and/or avoid pressure sore. Or some of them may have limited neck mobility. Examples of adaptive strategies and assistive technologies related to virtual teaching and learning include the following: some people may use keyboard alone to operate the devices. Some people may customize keyboard shortcuts to activate commands. Some may customize keystrokes typing options, change the mapping of keys, assign personalized shortcut keys to frequently used functions, set filters, and set sticky keys to support single-handed typing. For example, type single keystrokes in sequence rather than typing simultaneous keystrokes to activate commands, that is known as chording, for commands for special characters, shortcut keys, and menu items, etc. There are some ergonomic keyboard designs to cater to the needs of different users. For example, a key guard that is a plastic or metal cover mounted on top of a keyboard could facilitate people whose hands shake to avoid accidental adjacent key presses or duplicate keystrokes, such as for people with cerebral palsy. Some other keyboard designs may contain larger keys, key labels, key spacing, illuminated keys, or custom layouts. Examples of typing aids are slip-on typing or keyboard aid, and hand-strap typing aid. Some people may use the on-screen keyboard, a virtual keyboard displayed on a screen, so that it can be operated with a touchscreen, mouse, trackball, joystick, or other pointing devices. For pointing devices, examples of customization include the following: mouse with adapted design, trackballs, joysticks, and selection switches. Some people may customize their mouse and cursor settings to cater to their needs. Mouse and keyboard filters are functions of the operating system or software tools that recognize and compensate for involuntary movements, such as tremors and spasms. Customized built-in settings of the mouse, cursor, and trackpad include size, speed, and sensitivity, as well as alternative control options, such as changing the mapping of buttons, changing the sensitivity of the mouse to movement, setting filters, and setting larger clickable areas for buttons and links. The size and appearance of the mouse pointer can be changed. Double-click speed can be changed by adjusting the mouse or trackpad's reaction time when the person double-clicks an item. Scroll speed, or the speed at which a person scrolls through documents and windows using the mouse, can be customized, along with the dragging style of the trackpad. Some people with physical disabilities may use hands-free control to operate the devices. Examples of hands-free interactions are switches operated by foot, shoulder, sip and puff, or other movements. Head-mouth stick keyboard, mouth stick, and other aids to help with typing. Voice recognition software, which recognizes the human voice and can be used to dictate text or to issue commands to operate the device. Eye tracking, sometimes called eye gaze, a system that monitors eye movement to control the mouse pointer and detects blinking to initiate mouse clicks. Head movement, for example, moving the pointer using the movement of your face or head, as detected by the camera that's built into or connected to your device. Visible indicators of the current focus and mechanisms to skip over blocks, such as over page headers or navigation bars, to minimize the need of clicking, dragging, scrolling control for navigation. Error correction options, and large clickable areas that make it less easy to touch adjacent commands. These designs may help cater for the needs due to handshaking, trembling, and other dexterity limitations. Examples of accessible practices related to virtual teaching and learning include the following. Allow short breaks for live streaming sessions of long duration. Permitting students to record live-streamed classes for review. Allowing more time to type, click, complete tasks, or carry out other interactions. Allowing alternative modes of responses input, such as substituting a written response or a typewritten response with a verbal response for course assessment. About people with speech disabilities, they may have the following experiences. Inability to speak due to various reasons, such as anxiety, brain injuries, or inability to hear and learn speech. Weakness or complete paralysis of muscles that are necessary to produce speech, including lips, lungs, throat, tongue, and others. Difficulty or inability to produce certain sounds or patterns of sound, and sometimes results in addition, distortion, omission, or substitution of such sounds with others. Difficulty producing speech that is recognizable by others, or by voice recognition software. Loudness or clarity of someone's voice might be difficult to understand. Inconsistent articulation and production of speech sounds, and errors producing sounds in the correct order, so that spoken words or phrases become difficult to understand. Influent speech, repetition of individual sounds or entire words and phrases, and misplacement or prolongation of pauses and sounds while speaking that is different from cluttering. Increased speaking rate, incorrect rhythm, intonation, and co-articulation of sounds, and other influent speech that is sometimes similar to stuttering. And or other conditions that are not listed here. Examples of barriers related to virtual teaching and learning include the following. E-learning tools that involves operation by voice commands. Real-time communication with instructors and fellow students during online class that rely on phone chats or audio calls as the only means of communication, such as responding to instructors' questions and engaging group discussions with peer students. Examples of accessible practices related to virtual teaching and learning for people with speech disabilities include the following. Using alternative means of communication, such as emails or text-based chat. Whenever possible, enable alternative modes of operating e-learning tools, apart from using voice commands. About people with visual impairment. There are different types and extents of visual impairment, such as blindness, referring to the total blindness in both eyes. Low vision of different extent. An example is tunnel vision, referring to seeing only the middle of the visual field. Deaf blindness, referring to substantial and uncorrectable visual and hearing impairments. Variation in perceptions of colors and brightness, which can be independent of visual acuity, such as increased sensitivity to bright colors, as well as reduced or lack of sensitivity to certain colors, commonly called color blindness. In general, color blindness refers to the difficulty distinguishing between colors such as red and green, or yellow and blue, and sometimes the inability to perceive any color. And there can be other conditions that are not listed here. Examples of barriers related to virtual teaching and learning include the following. Learning materials in the form of scanned images of text cannot be read by screen readers. Take scanned PDF documents as examples. In general, these scanned images of text does not contain real text, which means the text cannot be selected, highlighted by cursor, nor edited. It is not accessible to assistive technologies such as screen readers. The text in an image of text would get pixelated when the images are magnified, zoomed in, or zoomed out. It would particularly make the text inaccessible to users of magnifying tools. No text alternatives, alt text, for graphical content. Screen readers cannot interpret graphical content. Without alt text, screen readers may only read aloud image or graphic or the file name. Users of assistive technologies cannot understand the graphical content. Images, controls, and other structural elements that do not have equivalent text alternatives for screen readers. Video content that does not have text or audio alternatives, or an audio description track. Text, images, and page layouts that cannot be resized, or that lose information when it is magnified or zoomed in. Tables that are not properly formatted would also be distorted and lose information when it is magnified or zoomed in. Lack of visual and non-visual orientation cues, page structure, and other navigational aids. Inconsistent, unpredictable, and overly complicated navigation mechanisms and page functions that might require complicated control of a mouse or finger touch input on a touchpad. Text and images with insufficient contrast between foreground text and background color combinations. The use of color as the only visual cue. People with color blindness, low contrast sensitivity, or some visual impairment may have difficulty distinguishing between certain colors. Therefore, using color as the only visual cue to convey important information could hinder the user's understanding of the content. Users who print out slides in grayscale, people viewing slides through monitors in bright sunlight or glare, and people viewing slides through a projector display in a well-lit venue may also be unable to differentiate the slide's colors. E-learning tools that have the following barriers. A lack of support for different color contrast modes. A lack of support for the use of screen readers. And a lack of support for keyboard-only control. Examples of assistive technologies and adaptive strategies related to virtual teaching and learning include the following. Customizing display settings, such as the styling and effects of the cursor or pointer on screen. Examples include the following. Size and shape, color and highlighter, speed, sensitivity, trail display, on-click effects, etc. Changing the size of your screen, text, or mouse pointer can make it easier for participants to follow along as you share your screen. Make use of a larger cursor to highlight and/or point to the main points of the content or the parts being elaborated. Take the built-in display settings in MacBook as an example. Go to System Settings, then go to Accessibility, then Display. In the Pointer section, customize the settings of the pointer based on your needs. Adjusting styling of the cursor or pointer on screen could make it easier to identify, locate it, and follow through. It may facilitate any students to understand the class content. Some may want to operate the devices and/or navigate through the content using only keyboard without the need to control the mouse pointer or cursor. There are some ergonomic keyboard designs to cater to the needs of different users. For example, a key guard that is a plastic or metal cover mounted on top of a keyboard could facilitate people whose hands shake to avoid accidental adjacent key presses or duplicate keystrokes, such as for people with visual impairment. Some other keyboard designs may contain larger keys, key labels, key spacing, illuminated keys, or custom layouts. There are screen magnifiers, some of which are built directly into the operating system of the device. These software tools enlarge the text and images. Take the built-in display settings in MacBook as an example. Go to System Settings, then go to Displays, then select the extent of screen magnification you need, such as larger text or more space. Some people may want to change the settings of the web browser, operating system, or screen to enlarge or reduce text size and images. Some people may use magnification lenses, binoculars, or other visual aids, and software such as screen magnifiers to better see the content. The picture on screen is a program called ZoomText to create a high-contrast display with white letters on black. Users can see the size of the cursor while typing. Screen reader software is an assistive technology that can perform text-to-speech conversion. Screen readers convert accessible text displayed on the screen into synthesized speech and braille. Examples of accessible text include readable text, images, buttons, or operating system elements with accessible text labels, and documents with accessible content. Screen readers work on computers and mobile devices. They are currently available for use, with devices running different operating systems such as Windows, Mac, iOS, and Android. Examples of screen readers include the following: JAWS, Job Access with Speech. NVDA, Non-Visual Desktop Access, available for download and use free of charge, and works on devices running Windows. And VoiceOver, a built-in screen reader in devices running macOS and iOS. There are also handheld devices with a smart camera that can read aloud text from printed surface or digital screen to perform text-to-speech conversion. The photo on screen shows an example of such device, called Orcam My Eye Pro. It is a voice-activated device that attaches to virtually any glasses. It can instantly read aloud text from a book, smartphone screen, or any other surface, and recognize faces. Orcam My Eye conveys visual information audibly, in real time and offline. Refreshable Braille Display. It is a mechanical terminal that displays a line of 40 to 80 Braille characters by raising and lowering the dots dynamically, which are pins. An example is the Focus 40 Blue Braille display. Examples of accessible design related to virtual teaching and learning include the following: provide text alternatives, alt text, for graphical content. Alt text concisely describes the content and the purposes of the graphical content in brief phrases or 1 to 2 sentences. Examples of graphical content include photos, shapes, pictures, charts, smart art, and graphics. Here is an icon with an example of alt text that reads, "The access for hearing loss symbol." A graphic of an ear, with a thick diagonal line crossing through it, between the top right corner and the bottom left corner. A capital letter T at the bottom right corner of the ear graphic. Alt text enables users of assistive technologies to understand graphical content. When screen readers recognize an image with alt text, screen readers will generally read image or graphic along with the associated alt text. You are encouraged to refer to the other module on the suggested practices of inputting alt text in different kinds of digital materials in greater detail. We may change the visual appearance of the text to achieve higher readability, such as the font type, font size, character spacing, line spacing, and paragraph spacing, punctuation and symbols, emojis and emoticons, hashtag, and text colors. For font type, for example, sans serif fonts are generally preferred to serif fonts. Sans serif font do not have decorative lines at the edge. An example is Arial. Serif fonts have small lines at the edge that may hamper readability. An example is Times New Roman. Avoid only decorative fonts or light fonts. Some users, especially people with visual impairment and people with dyslexia, might find it hard to read decorative fonts, and those whose letters are close to one another. Avoid using all caps or small caps for the text. Capitalizing all text is difficult for most people to read. Text with all caps or small caps may show no differences in the shapes of texts, and all the texts may visually appear like a single rectangle. It would particularly create barriers to some people with visual impairment and some people with reading disabilities. Ensure sufficient color contrast between text and its associated background. Do not use color-on-color background in text, such as light blue text on dark blue background. We may make use of software applications to check color contrast between text and its associated background. There is a number of color contrast checkers that are free of charge. Examples are the Color Contrast Analyzer from TPGI, the Adobe Color Contrast Analyzer, the WebAIM Contrast Checker, and the WebAIM Link Contrast Checker. To enhance accessibility, it is important to use distinguishable and multiple visual cues to present information. For example, red text is used to represent compulsory lecture, and green text is used to represent optional lecture in the course schedule. However, some users such as people with color blindness may be unable to differentiate the red text and the green text. Users who print out the slides in grayscale may also be unable to differentiate the colors. To improve accessibility, we may use multiple visual cues, such as color, symbols, and text, to indicate compulsory lecture and optional lecture in the table, respectively. For charts, graphs, or maps, examples of accessibility enhancing features include color, clearer borders, pattern fill, line style, such as solid or dotted lines, data labels, text description, and legends. For example, use color, pattern, and text labels to identify each section. Put the text labels near or directly on the corresponding pie section to enable readers to understand the chart clearly. Do not put all of the text labels below the chart. Selecting and using e-learning tools that support the use of screen readers, keyboard-only control, as well as the use of different color contrast modes. A high contrast mode may provide relatively better color contrast. Ensure clearly structured contents with a logical reading order to facilitate overview and orientation and improve accessibility. Reading order is the sequence in which assistive technologies, such as screen readers, will read the contents. You are encouraged to refer to the module on PowerPoint accessibility and PDF accessibility for the suggested practices of ensuring logical reading order of PowerPoint slide items and PDF documents in greater detail. A well-formatted and meaningful heading structure allows users to understand the semantic structure of the document better. Users could jump between headings to look for information from large piece of text efficiently. It may facilitate information processing. Users of assistive technologies such as screen readers and keyboard control may navigate the document efficiently by jumping between headings. Without heading structure, they may need to go through the whole document every time they want to look for certain parts of the text. It is suggested to keep headings concise, specific to the content that belongs to that section, and clear to someone new to the topic. A concise heading would also be useful to Braille display users. Refreshable Braille display may present up to 80 characters at a time. Other examples of accessible designs are information to guide the user's actions and notify them of errors. Images, form fields, buttons, or operating system elements with consistent and accessible text labels for access by assistive technologies such as screen readers. Avoid scanned images of text or PDF documents. As mentioned, scanned images of text is not real. In general, it cannot be selected, highlighted by cursor, nor edited. It is not accessible to assistive technologies, such as screen readers. The text in an image of text would get pixelated when the images are magnified, zoomed in, or zoomed out. It would particularly make the text inaccessible to users of magnifying tools. Use documents with real text or searchable PDF whenever it is possible. Real text can be selected, highlighted by cursor, or edited. It is more accessible to assistive technologies such as screen readers. The text in such PDF would not get pixelated easily when the images are magnified, zoomed in, or zoomed out. It would make the text more accessible to users of magnifying tools. We may try to convert an image of text content into editable text by optical character recognition, OCR. It could be a common situation of preparing reading materials. The screenshot shown on screen now is applying OCR using the Enhanced Scans function in Adobe Acrobat Pro. Besides real text content, tags are also essential for assistive technologies users to access the PDF documents. Tag PDF document content in logical order whenever it is possible. The tags will form a logical and expandable tree structure that allows assistive technologies such as screen readers to identify each element in the PDF and read the content correctly in the intended and logical order. A properly tagged PDF does not necessarily mean the PDF is fully accessible. However, an untagged PDF would not be accessible. You are encouraged to refer to the other module on the suggested practices of enhancing the accessibility of PDF documents in greater detail. Providing audio descriptions of video. Audio description is a term used to describe the descriptive narration of key visual elements in a video or multimedia product. This process allows individuals who are blind to access content that is not otherwise accessible simply by listening to the audio. In audio description, narrators typically describe actions, gestures, scene changes, and other visual information. They also describe titles, speaker names, and other text that may appear on the screen. Concluding remarks. This module provides examples of experiences, barriers, and accessibility needs of some people with disabilities, as well as the potential strategies, design principles, tools, and techniques that could better cater to their diverse learning needs and accessibility needs regarding virtual teaching and learning. Note that the categorization and naming of disabilities here do not aim to categorize people according to any medical conditions. The examples here mainly serve as illustrative examples. The categorization and naming of disabilities would vary across different perspectives, such as the adopted conceptual models of disability, different cultures, changes in the knowledge and understanding of the conditions, or changes in preferences among disabled people and advocacy groups. It is also important to note that students having the same types of disabilities may share some similar needs, but they do not necessarily share exactly the same set of learning needs or accessibility support. A wide range of factors jointly determine the learning needs, barriers, and required accessibility support. The factors would impact how they access digital materials and virtual learning environment. Examples of these factors include individual characteristics and preferences, program requirements, the accessibility of teaching and learning materials and environments, and the availability of certain tools, hardware, and software. It is important to talk to students to understand their needs and explore the required accessibility support together. Always do our best to consider the broad diversity of accessibility needs and learning needs of students. Do not determine and categorize students' accessibility needs and required accessibility support solely based on their disability types or any medical diagnosis. Overall, sessions and materials that are accessible to users with disabilities are also more accessible to many more users. Disclaimer.
This video does not contain any business promotion elements. Software, programs, and operating systems are constantly and rapidly developing along with changing accessibility functions. Statements in this video about the functions of any software, programs, and operating systems may no longer represent the current status. The recommended practices in this video are not exhaustive or the best solutions for each situation. It is possible that the hyperlinks of the cited resources in this video might be edited or removed by the corresponding contributor after publication of this video.
References. Part of the content of this module is adapted from the following two documents from the World Wide Web Consortium, W3C, Web Accessibility Initiative, WAI. The first document is Disabilities and Barriers in How People with Disabilities Use the Web. The second document is Tools and Techniques in How People with Disabilities Use the Web. You may find the full references on screen now. You may also refer to the text version of the reference list below the video player on the web page. Acknowledgement. This project is funded by the UGC Special Grant for Strategic Development of Virtual Teaching and Learning. The first author, Gloria Ma, would like to acknowledge the support of the postdoctoral fellowship scheme offered by the Research Grants Council of Hong Kong. This work is licensed under Attribution Non-Commercial Share-alike 4.0 International. To cite this video, please follow the suggested citation on screen now. You may also refer to the text version of the suggested citation below the video player on the web page. For more guidelines on creating accessible digital educational materials and virtual learning environments, please refer to our Virtual Learning Accessibility Toolkit at https://vlaccessibilitytoolkit.hku.hk or download the full text in PDF from HKU Data Repository. You may scan the QR code on screen now to visit the database. You may also download the set of cheat sheets for quick reference and sharing. You are highly encouraged to watch the other videos in this Idea Leaders Self-Learning series to enrich the knowledge of the basic concepts, practical tips, and resources of enhancing the accessibility of virtual teaching and learning. Here comes to the end of this video. Thank you for watching. Let's begin our journey towards co-creating accessible virtual teaching and learning.